Watch the complete playlist on the app Pions. Download the app now.
Calculate the equivalent resistance between point A and B. Okay. Now this is same as a Wheatstone bridge. How? Let's start with this point. Okay. Let me start from here. So from this point, if we start, pay attention. I am going like this. This is my 4 ohm resistance. How much? 4 ohm. Now another path is this 2 ohm. So let's go to 2 ohm like this. Correct? Now one end of this 4 ohm is connected at somewhere here. Correct? So let's call this point as this one. Which one? This point. From here, there is a wire which is connecting between 2 ohm and another side is 4 ohm. So this is our 10 ohm, which is here. Correct? 10 ohm. This is 2 ohm. Okay, I hope up till here it is fine. And one end of this 10 ohm, which is going to, look at this, 2 ohm, another end is going to another one, which is 4 ohm. So let's go to this one. This is our 4 ohm. Correct? And another end of this 4 ohm is going here, and that is connected to an 8 ohm, which is between the upper 4 ohm and this one. So upper 4 ohm is here, and this is our 8 ohm. You can watch this lecture again. Okay, how I explained this whole scenario. So this thing will be clear to you again. So I hope this is clear. Now, if it is a Wheatstone bridge, if it is balanced or not, that is more important, because if it is balanced, then the circuit becomes very easy. If it is not balanced, then you have to be very, very careful. Okay. So let's see if it is balanced or not. Sir, what is balanced or not balanced? Let me remind you, if a Wheatstone bridge is balanced, then R1 upon R2 must be equal to R3 upon R4. Sir, what are R1, R2, R3, R4? This is called balancing condition, where R1 is this one, R2 is this one, R3 is this one, and R4 is this one. If the ratio of these resistances are equal, like 4 by 2, here R1 is 4, R2 is 2, is it equal to 8 by 4? Yes. And if this condition is true, in theory we have learned that if the ratio of resistances are equal, not only resistances, even if there are capacitance here, if it is true, then the current through the middle branch, okay, that will be equals to 0. I5 was, when you must have done in theory, Wheatstone bridge. In that, I must have explained that the current through the middle branch, we take it as I5, or current through the galvanometer, then current through this branch will be 0. Let me repeat the whole scenario. If R1 upon R2 is equals to R3 upon R4, if it is true, then only the current is 0. These two conditions are called as balancing conditions of Wheatstone bridge. This is true only if these two are true simultaneously or together. It's not like, sir, if R1 upon R2 equal to R3 upon R4, is it necessary I5 has to be 0? Yes. And if I5 is 0, this has to be true. Both holds together. So here it is satisfied. And if it is satisfied, no current is flowing in the middle branch, then you can remove this branch. No sense of keeping it. No current, no use. Simply, if there is no current flowing in the middle branch, it is simply saying that it doesn't exist. Okay. So there will be no resistance offered. Now, sense is, if you don't have current, what is the sense of resistance? If someone is not walking on any track or any path, how can you say it is a path if there is no particle? So similarly, if there is no current flowing, there is no sense of resistance. Resistance is the property which opposes the flow of current. So if no current, no sense of resistance, right? So no resistance in the middle branch. Now you can see it's a very simple circuit with 4 ohm and 8 ohm are in how much? They are in series. So 4 and 8 will be, upper branch will give you 12. This is again reminding you A, this is again B. 4 and 8 is 12 ohm, and the lower branch 2 and 4, which is 6 ohm, connected in parallel. So what will be our equivalent? 1 by R equivalent will be equals to 1 by 6 plus 1 by 12. So let's take LCM. 12 here, 6 2s are 12 1s are 3 by 12, and taking the reciprocation, R equivalent will be 12 by 3, which is 4 ohm. So what is the equivalent resistance between the points A and B? it's 4 ohm.
Watch the complete playlist on the app Pions, download the app now.